Kim, do you want to kickstart?
Yes, I will. All right, it is now 9 o'clock. Today's presentation is just chock full of information. So instead of giving the customary 4-minute, 5-minute buffer zone to say hi to everybody, we're going to go ahead and jump right in. Oh, never mind. Good morning, Walter. I can't help but say good morning. Okay. Hello and welcome to Strayos' webinar, Strayos Under the Hood, the engine driving the mind-to-mill AI. My name is Kim. I'm General Manager at Strayos. Presenting today are Brad Gyngell, COO at Strayos, and Ravi Sahu, CEO of Strayos. Brad spent the first phase of his career helping over 100 sites optimize drill and blast activities as a mining engineer with the world's leading explosives providers, Orica and Dyno Nobel. He then expanded the scope of his support to encompass all commercial and operational functions by moving into management consulting with the top tier from Boston Consulting Group. Brad holds a B in engineering from UNSW and an MBA in finance and entrepreneurship from Carnegie Mellon University. Ravi Sahu is CEO of Strayos, a cloud-based software company that develops drone data analytics and artificial intelligence solutions for the drilling, blasting, and mining industries. Formed in 2016, Strayos is used in hundreds of sites across the world. A couple of quick notes before we get started this morning. Please make sure to put your questions in the question section rather than the chat box. You can see it as a little black voice bubble with a question mark inside it on the top right-hand corner of your screen. We will be sending out a link with the recording of the webinar after the webinar has finished. If you would like a certificate of completion, please email us at hello@strayos.com. We will be emailing answers to all questions asked within a couple of days, so please don't be shy about asking, especially as today there's a lot of content and we're not sure how much time we're going to have left over for Q&A. So without further ado, Ravi Sahu.
Well, thank you, Kim, for the introductions and setting up the groundwork here. So as Kim mentioned, feel free to let the questions flow as we are engaging in these sessions. There's a lot to cover today, and this is the topic. In general, we can go for couple hours to almost like 2 weeks just to discuss this. But I'll do my best to summarize and also cover nitty-gritties of the mind-to-mill AI here. And without further ado, I'll jump right in. So the topic for today's session is Strayos Under the Hood. And what we thought is, in our webinar series that we have done so far, we have picked a use case, or we have picked a case study type of format to kind of share the knowledge and share the understanding of what we are seeing, either related to the drill and blast or post-blast, how we can benefit from the analytics. Today's topic is like really going and sharing how it gets done and what's the mechanics behind it. A lot of the times it looks like a black box, and that's what we want to kind of unpeel or like peel those layers about like how this data analytics happens behind the scenes. So today's agenda is a bit of an introduction about Strayos and why the transition to AI is one of the topics that I would like to cover, how it can benefit, and really going in deep dive sessions about how fragmentation, rock mass, stockpile, and hot rod AI gets developed in Strayos platform. And then Brad will take you to really sharing about what is this mind-to-mill AI can unlock several opportunities within your organizations here. And like I said, we will have Q&A, but as you are hearing and engaging, feel free to kind of, post the questions. We'll go along that. For those who are repeat attendees, probably know more what Strayos is, but I think there is always a new audience here, so I'll do the dance here of introducing Strayos. So we founded in 2016. Roughly, our platform is used in 8 countries in around 600 mines. And our predominant use cases and the platform that we have developed serves drilling and blasting customers, quarry customers, and also large mines as well. We have teams in few different locations and 3 different time zones, as you can see, in covering like 24/7, which gives us ability to do customer support at any given point of time. And the KPIs that we track is really cost savings on digital and blast, and how the material quality has been improved, or the overall cost per ton improvement we are seeing in our customers location and site here. Uh, Again, how we have developed the platform is it's a set of or suite of chronological tools that let you do the job as an engineer. So a lot of design tools are developed in one platform. So starting from surveying and planning part, which your photogrammetry data can be inputted, and you can generate models. And the same data can be utilized to discover various types of insights, like the geology analysis. You can plan full drill plan, send it to the drills, or send it to your rovers for the staking, and then suite of blast loading and timing designs are there. And further to that, after the blast, we have suite of fragmentation and post-blast analysis tools, along with the loading and hauling analytics as well. So that's what we call not only tools designed for the field personnel, but also overall overarching information of what are the optimizations we can drive, since now the tools and the data has been flown in one place, and how we can unlock different types of information. And that brings to this point of, now you have the data in one single place. What are the other things in terms of the optimization you can do? This data is stored not only geospatially, but in a time series form. And when we combine these 2 types of data, you can generate a lot of intelligence, from it, and you can run not just what happened, but also what if types of scenarios. And that's where the power of AI kicks in. So we've been into this mode of understanding our site, but I think the understanding of the site gives you what we have accomplished. But we moving from the current state to the future state, that's where the optimization everybody wants to do. And optimization, as I've always said, it's not just one single project or continuous improvement. The name itself says continuous improvement. It needs to happen every time. And one KPI gets accomplished, you continue to move or challenge that additional KPIs. And that's only, we see that when you have the data structured in such a way, it leads to those KPI optimization. So the question is, like, why? Why should we really look into the AI? The things are going, there are a lot of great tools are out there, and it accomplishes its job. And you, as an engineer, everybody is using those tools up to its best extent. But why there is a need to transition to AI? And I think that's one of the key focus that I want to drive down in today's discussion is why and why not, right? So, but let's first understand what is AI is, right? A lot of the times we have this factor of like AI is going to come and it's automate everything, and it's going to make things redundant, in terms of the human skills. But I think it has gotten a bad rap in terms of how the AI needs to be utilized. We always think about autonomous driving, autonomous, everything autonomous, but I think there is a lot more to that, how AI can be leveraged, and especially in the mining scenarios where you have lots of data that comes in. But let's just first understand what AI is. Just nothing but programming of algorithms, and humans are much smarter in thinking and coming up with innovative concepts and ideas. And AI is just taking those concepts and repeating it and programming it at a massive scale. That's where the machines kind of, or the computational part and the ability comes in. So you can program the algorithms and then you can train it over and over again. And that gives an ability to test different scenarios at a speed of millions per second, test different hypotheses. What if I want to optimize my drill and blast KPIs to not only understand my cost per ton, but also environmental part, vibration part. But what if I throw in another factor of yield part there, how my drill and blast optimization will look like? So this hypothesis testing can be done at a scale within few seconds. So this is what where the AI gets really powerful here. But when we go into the talking about the maturity part here, let's so in terms of the maturity here, there's a lot of things to talk about here. What essentially the category of AI is. What we see is most of the mining companies, they are experimenting with AI since they have data. We see that it can be categorized in three different levels here. Is one is the assistive intelligence, and this is what we see in most of the companies which are experimenting or running proof of concepts, and where you are developing and training certain AI models that execute similar type of task that would essentially more of a dull task, and that can be taken and wrote a program or macros that you have already familiar with, but now you can do it for at a massive scale. And that's what this assistive intelligence of AI looks like it. Right, so the decision making is still in the hands of the users, where after the AI generates the result, you are making the decision yourself, how to better interpret the end results here. And then there's another format here called level, augmented intelligence, where AI and humans learn from each other, where you have trained a model to look for certain anomalies, and you know the anomalies yourself, but now you have trained it where AI is automatically picking those anomalies. But after a certain period of time, if AI gives you a better understanding of those anomalies that you have not thought about, now the humans can, as an engineer or as a user, can better see these anomalies were not thought or considered earlier. So you can get those type of intelligence. So calling is more of augmented intelligence, and you can glean different type of insights, from those augmented data points here. But the next level that really, which is the third level, or kind of where it becomes much more powerful, where you're moving from a proof of concept kind of enterprise level AI stage to really deploying at a strategic scaling of the AI that you're leveraging there. So the AI is not only capable of insights that has been generated, but also acting and making improvements on those systems. So for an example, if you have considering the mine scenarios where you have machines or machine guided systems, where it's seeing different sizes of ore in a conveyor belt, but and then after the oversize has been detected, it automatically classifies. So the machine itself is classifying and sorting, things there. So that's where the autonomous intelligence, comes in, where the machine itself is making those decisions, and it does in a way that is very non-intrusive in a pattern. So this is what the AI maturity curve, and it's important to understand. And this level kind of is described by the Global Mining Guidelines Group, which is it's a body which is putting together all the AI scenarios, for the industry in general. So now we have a time for one quick poll here that I will launch. So if we can spend 30 seconds or so to see how much you're using AI in your day-to-day operations. So it is interesting to get these responses. Yeah, so we have quite a, oh, I think there's a lot of responses obviously not using. Well, it's there's a lot of trials going on right now. We'll give it a few seconds to see where we land. Right. Thank you, everybody. So I'll stop the poll. Thanks for participating in this poll. Very useful responses here. So when we think, we just learned about the AI maturity curve, but our mining enterprises or the industry in general, when we talk about the different operations of the mining, drilling and blasting, loading, hauling, and then the milling side, are they set up to leverage AI? That's the fundamental question here. In not only just the mining, and even the aggregates or coring operations, are those set up to leverage. And the way I see it is, mines are constant moving factory, and it's a very complex enterprise where a lot of things are changing every day. Not just the mountains are moved every day, but also a lot of things are being changed from the operational perspective. And whenever there is this much of complexity is there, not just in terms of the people management, but also the operations management, it creates a lot of inconsistencies here, right? So let's just talk about what are those inconsistencies we can see here. We'll discuss more on that, but to first set the premise here, you can see mines generate a lot of data. And these data sources are not only unique, but highly powerful in terms of what you can glean, information from, right? For your decision-making perspective. We have laser scanners scanning the areas or face. Drones are, become a lot more ubiquitous tool in every site these days. Before that, satellite data was, very useful. It's still being utilized in large scale scenarios. LiDAR is one of the another data set that is powerful if you are looking from the terrain modeling perspective and the accuracy side. But more importantly, now you have this phones and pictures that you are collecting. In your this powerful tool in your pocket, you're gathering a lot of information from there, either just for documentation perspective or even modeling perspective as well with the latest iPhones here. And then the thermal side, which is looking at the blast scenarios during the blast, gas ejections and other things, are very powerful. But overall, plant monitoring as well. So we have lots of data coming out, what we call these data sets as a computer vision data. So it means anything which is visually representable, it's a vision type of data and information. And one of the latest in the stack is the hyperspectral imaging sensors, which able to classify mineralization layers as well as different types of ore bodies, in the active mines, greenfield, as well as the post-blast, ore segmentation between high grade and low grade as well. So that's what we call the computer vision data stack. And then the another types of data that comes in as machine sensor data. So you have lots of sensors floating around, either in trucks, crushers, your drill machines, so equipment data, as well as the what called the Internet of Things as well. Those data are also getting pushed, right? So massive amounts of data is being generated, and then the third is the spatial data, which is your surveying, either through your GPS equipment or RTX network that you're leveraging for your site. And the geophysics side, which is looking at electromagnetic data, radar data, anything where your subsurface information or geological characterization is happening. So the way I see, this is an enterprise which not only generating a single type of data here or the temporal types of data, but this is a combination of visual data, sensor data, spatial and geophysics data. So how do you handle this? And then this begs this question of which I've read this somewhere, and human brains are not good in retaining information over a long period of time. And I think I can attest myself, to that, where I read something, and if you ask me after 6 months, I would not retain that information. But one of the things that I, fully agree is we are good in generating ideas. We are constantly coming up with new systems, new ideas. Uh, and so all this data that's been generated, how do we better glean insights, from that? But if you're not able to retain information, if you have more of a people-driven organization, which are really good in doing their jobs, really good mining engineers, drilling engineers, and they're best at their jobs, but the knowledge, information kind of retains in their brains, and then if they are coming up with their own new systems, but how do you unify that? And that's where, when you have a lot of different type of data sources, it creates data silos. And this is one of my uh, thinking that the more data silos we have, the more slowness in decision making happens. Um, we have moved from the systems where we have worked on these standalone systems where one department is doing a resource planning, or they are using certain types of softwares to do resource planning. And then your mine planning tools, geology modeling tools, and surveying department or surveying tools are completely different. IoT data to stack is completely different. But we have seen these organizations which are thinking about digital transformations. They are also now started to integrate some of the tools, but it's still not fully integrated, right? So these are half integrated systems. And then again, it creates decision-making, problems. And so it is becoming a single source of truth for that specific tools, but not for the entire process, or not for the entire, when you look at the value chain, when we're thinking about mine to mill. But how do you solve that? You have to think in terms of platform systems here. So if you can unify all your tool stack, and the data can flow from every time you're doing a mine planning or mine plan update, your geology modeling is getting updated. Or if you're doing a surveying, the information seamlessly flows into all this workflows. So it's not only updated, but also it's automatically getting pushed to the resource planning stage or the commercial stage as well. And every time a machine is generating the data, it gets pushed in all these three layers. And that's what brings to the unified organization or unified enterprises here. So uh, that's where I see a biggest beneficiary organizations can have from the machine learning and AI. Here, it can help bridge the data silos and help generate contextual, intelligence. So moving from what to why. So what helps me understand if I'm using a specific tool. It will help me understand what type of design plan I need to update, but why? Is there any other types of impact with that design plan is going to create? So this type of contextual intelligence can AI can derive from, and then moving from complex enterprises to the streamlined enterprises where information is seamless here. So let's now, since we have set the premise of like why the transition to AI can be beneficial to the mining enterprises here, which most of the questions were posed related to the data silos and how we can better structure so that the information flows, and we are set up to leverage the AI better. But now let's really talk about how it gets done, which is like really peeling the layer here and understanding how the AI, and we're going to go into these specific examples here. So uh, the way I see is every organization goes through this phase of uh, doing a digital transformation or digitizing, even starting at a very low level, or if we have to just digitize your moving in from pen and paper log to Excel based, which is again a digitization. And this kind of what it's a setup part of how do you set up so that you are truly set up for the success here. Uh, so we've seen siloed manual workflows, different people working, and most of them takes time or even impossible to run different statistical models, and that's why there is a need of one unified system here. So one of the things that as a part of Strayos, what we have is this engine that drives this different, uh, siloed information and brings, things together here. So really kind of, we go after the center of the problem where we can bring all the data together. And then Strayos engine allows you to refine and organize all of that data in one modeling environment. So you have data coming from different sources, which we call our data ingestion pipeline. And that data ingestion automatically filters the data or structures the data that helps you in scaling that analysis from one site to another site. So if you're an organization, you're trying to optimize not just one site, but also how I can glean the same information and apply into my other 10 sites. And then also you can either go it very broad or go it very granular as well, and it helps you think and helps kind of your open up the mind and a brand new way of like thinking about how I can design my drill and blast in one scenario that has a similar type of effect on my other sites because it has a similar type of geological data. So this is what it brings all this information, and you can see the data layer gives that ability to structure the data. And then the AI model layer, once the data is been structured, we have several, a library of models which can pick and choose what type of models to run. And these models are constantly improving in the background. These models are also customizable. What that means is it doesn't has to be re-architected or redo. If you have a situation where you're trying to build another types of insight, so the same models can be applied easily. So your deployment time, gets shorter from let's say a 6 months to 2 weeks. So that's what the customizable part comes in. But the crux of the other part that I see, which helps is scale, is this high performance computing, right? So it's the real time data analyzations on a shared platform for continuous improvement and visibility of your operations for all departments. So drilling and blasting, post blast, milling team or plant team can come together and leverage the same information in one platform here. And it has auto scaling and on demand execution that can happen in one view here. And these models that we have developed, it's not only derives kind of the information and turns this proxies into different type of properties like rock properties, but also helps you lead to the certain KPIs, which is blastability, diggability, and crushability types of information can be derived from here. And as you can see, after the data and AI models does its job, it gets stored. And then at the end, you see in the Strayos 2D and 3D viewer, you will see all this data represented in a reporting format, and all your data is being cataloged here. So going further deeper here, how it actually happens. So a lot of the information we derive is from pixel and the metadata, and every pixel counts. And that's the core of everything that we do. And so we're gonna go more into the use cases now. When I think about the use case, I picked 3 or 4 use cases here, and I'll walk through those behind the scenes how the AI works. It may be relevant for some of you guys, but I think I'll do my best to keep it as a high level so that it helps you understand better what goes behind the scenes here. So let's go into the understanding of this fragmentation AI, how the data is gets prepared. So we have the source data that you are collecting either from drones or the photos taken by phones. And once it's fed into our engine, it generates the elevation models. And also it has the imagery metadata. Imagery metadata is very powerful. It has not only the orthographic kind of types of information, but also camera information that can be leveraged to do all kinds of analysis, like the depth mapping, understanding, and which is highly useful for the fragmentation analysis because all we are dealing with understanding of true depth, height in each rock size, right, and the edges. But a lot of the times, these DMs are not good enough, as you can see, because DM sometimes, if you're just looking at the height domain, mug piles, could look like also a hill, and you cannot differentiate between those, two structures, properly. Uh, and then the rock textures separates these hills and real mud piles. So we are also applying the textures as one of the data to prepare and run analysis on that or prepare AI model on that. Going more deeper here, so after you've prepared the data, the next step comes in is the labeling part. So all the information that we have understood and the data that we have prepared, now we start labeling to really train what humans see, the AI should see exactly as it is. So no kind of differentiation, but humans see at a certain scenarios. That's where the power of AI can be scaled to millions of time, faster and better here. So we have a combination of domain experts from a specific type of knowledge. So fragmentation experts, who are doing this data labeling. And we've also developed custom algorithms to scale the labeling part. So every time a new type of data comes in where the AI doesn't do a good job, it auto labels and then prepares to see those anomalies for the same type of data set for the new time, next time. And typical problem here that we're trying to address is how do we separate the high wall better in this model, muck pile better, and then the background better. And this is what we call the segmentation engine that Strayos has. And we've written separate types of segmentation classes, which helps avoid or forces not to mix between the benches and the Stockpile as well. So as you can see, it detects and separates automatically. This is a bit of complex, things. What the picture looks complex, but what's the idea here? So you feed an image, which is your once you push all your drone pictures, it takes all the input image and breaks down further into smaller tiles. So all things are happening behind the scenes. The result you might see 30, 40 minutes, you get the result. But there's a lot of computations happening behind the scenes, which is not only breaking these images into tiles, but running this AI at every single pixel to extract those information about the rock edges here and also the boundaries. And at the end, what you receive is this segmentation map. But as a end user, I we don't know what this segmentation map classifies. So we further take this and prepare it more as a user-driven reporting here. So looking at the accurate segmentation here, we have two different types of problems again. A lot of the times, your rocks are laid on top of each other, as well as sometimes the photos itself are captured in a way at an angle that it doesn't look at exactly the same rock. So we have semantic segmentation, which not only predicts the edge accurately, but also the center of the rock. Then there's another type of segmentation called instance segmentation, which helps determine not to mix the rock, which are placed closely to each other. So you can see that's what the segmentation is happening here, which is really clearly demarking or separating out those rock layers. Uh, but the data itself, would be useful if every data that comes into the platform is all, perfect shape, but it's never, the scenarios, mining, as I mentioned, the data itself can be not perfect. So one of the things in the AI, there is a technique called augmentation, where you're training your AI to look for scenarios by generating different types of data during the AI modeling step, which is if I rotate the geometry of these pictures, how it will look like. So rotation, scaling, and then the spacing side as well, which is the color side. Uh, it should work in every other types of scenarios. Either it's a coal mine, metal mine, or every rock color textures are different and the colors are different as compared to limestone or the other. So it should work in different scenarios, and that's where the data augmentation, where you're preparing the pixels to not only adjust for the brightness, shadows, colors, and the noise of the information as well. And then the multi-scale inputs. Previously, as you can see, there's a lot of scaling required in the fragmentation side, but now it auto scales, depends upon the size that has been detected, and it auto recognizes those. And the post processing, so now your model has been done and trained, and you're getting the results now. So the post processing, again, it's smoothing the results, which is looking at different types of visualizations. So this is one rock which is like really going. If you see, the boundaries are being clear, but this rock is has a height information here as well, which is clearly being separated to consider that as a statistic. So that's what more inference learning. And as it sees more, it becomes better and better here. In this case, again, differential analysis of predicted scale to the rock boundaries. Here's we have rocks which are looks like there is a edge here, and that's what also get picked up. So and it can detect up to anywhere from 1 centimeter level to the others up to 10 meter to even more further here. But at the end, what you see or what as an industry wants is not the AI. the industry users want, the report, right? And this is what it gets generated as a dashboard, which means we are taking each individual rock size, storing it automatically, and then putting this information at different kind of scale and plotting this curve, even with the different types of analysis, 2D or 3D fragmentation analysis, which is looking at the height of the mud pile in the rock center to calculate the volume of that individual rock to give you a better sieve size of analysis here. The second use case here is the rock mass AI. And this is a different type of AI model development. And I have a poll for you guys again to see what's the most detailed view usually have for rock gianting before the blast here. So I just activated the poll. So there is a lot of use case related to the drill logging here and visual inspections as well. So that's very good use case. So I'll take 3 more seconds and we'll close it. All right, well, thank you. So it seems like the visual inspection is one of the key things before the blast that everybody looks for about joints and seams identification and mapping them for your blast and drill planning purposes, right? So that's another areas where rock mass information can be automated, utilizing AI because it just sees and identifies pattern more faster here. So it identifies joints, faults, bedding planes, and clusterizes these geological features in the 3D orientation environment here. And the pipeline is kind of different than what we saw for the fragmentation. The fragmentation was more about separating different rock sizes and the edges and then building the calculations and model. But here, what we're trying to identify these joints and bedding plane and developing this numerical understanding of where my bedding plane and the strike directions are going, right? So that not only you can plan your high wall stability analysis, but also the future pit planning as well. So the steps are it's exactly the same where you have generated the 3D model using photogrammetry. You upload your drone pictures, and after the 3D model is generated, we are running this AI in the 3D layer. So it's a unique type of data that we are utilizing to extract information because it detects AI on separate textures that has been generated in the photogrammetry models here. So you can see you have a 3D model. And the reason is 3D provides a better perspective once the model is generated for not only for the orientation, but also where that whole bedding line is going in an entire model. If you look at only one picture or two picture, it doesn't give you that perspective. And that's where the texture becomes much more powerful data to run AI here. And the way we separate is so not to detect on the other areas is we create a gradient mapping so that it automatically kind of filters the areas that where the AI should not detect the joints and the spacing problems here. So you can see here the drone pictures converted to 3D models and separate textures. Lots of areas it's been first mapped and detected each pixel wise and has a direct reference to the georeferencing site. So you can locate and extract at 50 feet of interval. There is a bedding line going on. I have how thick it is. how long it is, those can also be extracted, since it's all the AI has generated that georeference points as well. Going more deeper here is you can see the major 3D lines are determined and extracted kind of in a red color with the coordinates information. And that can help you plan your drilling and blasting in a much more data-driven way here. And once this information is generated, you have different types of grouping that you can do for your stereo net analysis, which is more the geotech side. Diving more deeper into more use case, Stockpile and Haul Road, again, it's a segmentation approach. As you can see, what's the ground truth and the prediction. It looks more spot on. But one of the differences that I see is a lot of the times when, as a human, when we are drawing the stockpiles, we are clicking only few points, and that could have result in few plus and minuses in the data point. What AI does is it draws the bounds so tight in the toe that your results becomes a lot more accurate in terms of the data point. So that's another use case of AI. But where not to use AI, that's another thing that we need to understand. Not a lot of the times AI is always a perfect solution, right? And one of these use cases with Haul Road AI, which detects large models, which detects the roads and various issues, but it has a combination of the traditional approaches, which is the computer vision or image processing algorithms to identify the pixel information and combine the half AI here. Because if you just use only AI, it creates a lot of noise in the end results. So that's another use where not to just only rely on AI, but also use the traditional approaches here. So now we have reached to the point where I'll let Brad jump in and talk about how AI can transform mind to mill. And it's also the time for poll number 3. So I'll just open up the poll. If you can take a chance in answering that. So how are you currently managing blast performance improvement? Okay, so we'll close in just a couple seconds. Interesting responses here. So that's everybody's doing continuous tracking, which is great. Thank you, everybody. So just as a summary, we've seen like why the transition to AI and why not as well. What are the data silos can create this slowness in the organization, and what are the opportunities? And we looked into the different ways of doing the AI model development here, and more of a behind the scenes approach. And now I'll let Brad walk through what are the use cases in mind to mill AI.
Yeah, thanks, Ravi. So yeah, first of all, really interesting results from that last poll there. It seems like everyone is focused on improving their blasting operations, with the majority of those results falling in the middle two buckets of people trying things every once in a while, or trying continuously tracking and then making changes as they go. But only a few people in that final category of looking at the blasting inputs and performance in the context of their downstream performance as well. So loading and milling performance. And really what Mine to Mill is about connecting all of these different pieces of data from across the value chain, putting it in one place, and creating this feedback loop that you see on the screen now to really optimize that decision making at the start of the value chain to get the best results out of the end of the value chain. So the way this works is that you have this input data over here, and you see we have that kind of broken up into different categories. You have your designs, so you have drilling design, explosives, loading design, timing design, things like that. And then you have QA, QC, so you have a lot of data measurements made in the field, really, on how well you actually executed that design. So it was all well and good that you laid out all of your holes with this perfect burden and spacing, but how did the burden and spacing actually look in the field? What were the actual face burdens based on the actual locations of those holes? And how much explosives did you actually put in those holes? Was there a cavity or something, or were all of the holes slightly shorter than expected? And so you take the design data, you look at what actually happened, and then you have to take into account the contextual data. You have to know what the rock was doing there. You have to know what the jointing was like, what the rock hardness, the type of rock was like, and you have to also take into account where the ore was, if you're looking at dilution, for example. So you take in all this input data, and then you need to get all the performance data in the same place. So you need, in the same platform, to have your blast results quantified. So you need fragmentation analysis done in a way that can structure that data in a way that can be useful. You need muck pile movement, similarly, not just modeled and visualized, but actually quantified and structured into metrics that can be compared blast after blast. And same with vibration and air blast data. And you don't just need the blasting results. I think this is where we kind of move from that second option in the poll, the third option in the poll to the fourth. So where you start unlocking huge value is when you start incorporating other data from downstream in the value chain, like dig rates, crusher throughput, mill yield and recovery data as well. And then the associated costs with all of this stuff. So not just the costs of drilling and blasting, but the costs associated with the other steps, the following steps in the value chain. So if we move on to the next slide, I'll give you a bit of an indication of kind of the size of the opportunity here. So we're not just talking about slight changes, slight adjustments. If you're optimizing your drilling and blasting in the context of your mill operations, we're talking 5 to 20% improvements in site costs or site throughput, depending on what you're targeting. And this is because if you can get that end-to-end view, and you can run this through an analytics engine, you can make much better decisions, which can save you huge costs in not just your drilling and blasting, secondary breakage, but then into your loading stage of the value chain, and then can start to have a huge impact in some of your major spend buckets like diesel consumption, mill consumables, power draw. All of these huge spend buckets for mines are directly linked to blasting performance. Similarly with throughput, in most mines, you have the large equipment in the plant or the mill as the bottleneck of the site. The way to increase the throughput through that bottleneck, which is often crusher or SAG mill, is by improving the fragmentation upstream at the blasting stage. So it directly addresses that bottleneck, meaning that you can get much more throughput through that piece of equipment. So let's move to the next one. So obviously there's huge value that you can get from doing this. So what do you need in order to get started? The things that you need are really you need to have this mind-to-mill AI model built that can, that can take all this data from across the value chain, associate it with each other, do the optimizations. You need all that data to be in one place. But to contribute to that single data platform where it's all in one place, you need a lot of other AI models whose job it is to basically parse and interpret and structure this data. So you need those geological AI models to look at your visual and 3D geospatial data and structure it in a way that can then be used by the mind-to-mill AI model. You need to have equipment sensor models that can take in measure while drilling data and turn it into something useful like rock hardness, and then turn that into something structured that you can use in a mind-to-mill AI model, for example. And the interesting thing about these enabler AI models is these need to be trained on super broad data sets. So while your mind-to-mill AI model, that might be getting trained on just your site's training data, you want these enabler AI models to be trained on really broad data sets coming from across the industry. So getting these fundamental AI models in place is really valuable. All right. The other advantage of then once you have those models in place, and then once you have that single platform there, and then you have that mind-to-mill AI model at the top, is that it doesn't just provide benefits for operational optimization, but it also provides benefits across safety, environment, and community. So you can use the same models and the same types of models for things like preventing slope and dam failures, automating kind of haul road inspections, checking berm heights, things like that, automating tasks that would put people in unsafe locations, situations, that kind of thing. You can also use them for environmental applications, such as rehab, measuring the biodiversity around your site, and then also reducing carbon emissions. So this has direct impact into some of the main emission sources from site, like fuel consumption and power draw. And lastly, you have community impact. So, the easy ones to point out are that you can straight away use this to start reducing vibration, air blast, things that disturb nearby dwellings or industry. You can also help minimize damage to sensitive locations nearby. So a lot of this is around preventing the harm that's being done. But there's also bonuses here. Zooming out, you're also creating new high-skilled jobs in your local community. So that's it for mind-to-mill. Like, in summary, it's basically an area with huge opportunity to create massive value for sites. There's some key things you have to get right, but the benefits are huge and extend far beyond the operational optimization there. So thanks so much for listening, everyone. Let me pass back to Ravi to close everything out.
Yeah, thank you, Brad. Well, I want to thank everybody in the attendance and the audience here for taking the time today. It's a topic that, as a company, we are very passionate about how the mining and the data and the AI can be useful and applied to solve the bigger challenges that everybody faces on a day-to-day basis. So if you have any questions or anything that you want us to brainstorm, feel free to reach out to us, either me and Brad directly. And we're almost at the top of the hour here. So we did said that we won't be having a time for Q&A today, but we will take a couple questions here. And I can, if you have to drop, feel free to drop. But we're gonna take a couple of questions which has most votes. So the first question is, what's the accuracy of the fragmentation prediction from whole blasted muck pile? So the accuracy is really we have tested the ground truth data. We have put some scales in there. We've marked actual rocks, as well as golf balls and the other. So there's a lot of scientific or lab testing type of ground truthing has been done. And the results coming out of the AI was pretty spot on measurements for the entire muck pile area. So it's fairly kind of the same sieve size information was produced at the end compared to the ground truthing that was done manually. And there is another question here which has more votes. So how the joints extends inside the rock mass is confirmed. Many times bench faces are not cleaned or filled with dirts. So they the detection of the joints and the bedding planes, it's all based on the visual data. So anything that's visually representable, that's what AI is also detecting, and it's just detecting much more faster and much more kind of precisely. But if it's something that is going beyond a visual identification, then that's also is not will not get recognized by the AI as well. And there's one question here, more. I believe that's a question I do like to answer. I said two questions, but this just came right now. Is there a risk that AI could make humans less intelligent and get used by people that would not have the common sense to know the answer from AI? Maybe wrong. So I think then there is a more follow-up question there. I think an exercise years ago where my students were going to the tablet GPS, and I have to say, I do not care what the tablet GPS says. So I think the underlying question is whether the AI would make humans less intelligent or like get used to the not using the common sense. I think the way I see that's kind of everybody's opinion is different here, but yeah, AI is simply scaling the information at a millions of kind of data point level. Yeah, it's building an insight to better empower the humans. So it's going to only make, at my perspective, it's going to make humans more aware. They will have a lot more contextual intelligence and the situational awareness intelligence. So it's preparing them for a different type of a smartness or intelligence than right now. We are only looking at how I can get my job done with one specific scenario, and transitioning to kind of more of this type of scenarios will have like more contextual and situational awareness intelligence. With that said, we will answer all the other questions as we always do. We will send an email with the summary and the response. But I appreciate everybody's time today and sticking around. This is our monthly webinar series as we continue to bring more topics. If you have any specific topic that you are interested in learning more, feel free to also propose the topic to us, and we will cover that as well. Until then, thank you, everybody. You have a great rest of the week, and see you next time. Bye.